Hello, my lovelies. It's Susanne, and today I want to show you how to solve this problem. The three squares in the picture have side lengths of 6 centimeters, 10 centimeters, and 16 centimeters. We can see our three squares here, and here we have the side lengths again. What is the area of the red trapezoid? Okay, so we have this red trapezoid in here, and we have to find the area of it. And if you don't know the formula for the area of a trapezoid, you could also divide this trapezoid here into a rectangle and a triangle. But I want to work with the formula for the area of a trapezoid here. It is a fraction. Here we have base 1 that is added to base 2. All of this is multiplied by the height and then divided by 2. What is b1, what is b2, and what is the height of our trapezoid here? b1 and b2 are always the sides that are parallel to each other. So here we have this side that is parallel to this side. So this is b1 and b2. It doesn't matter if you call this b1 and this b2 or switch the two, but the two parallel sides are b1 and b2. And the height is then the distance between these two parallel sides, the perpendicular distance. So here we have this distance because we know that this is a square here, so we have a right angle here. So the perpendicular distance is this part here, which is just the 10 centimeters. So this is my height, and I can insert the 10 for my height already, so that my formula looks like this. I only need b1 and b2 then to find the area. So let's try and find b1 and b2. Okay, so we need this part here and this part here. We also have this line here that goes from this corner up to this corner. And we can use this line to find these lengths. How? Well, there are several ways to do this, but one way would be to find the equation of this line as a linear function. So if we use a coordinate system, so maybe we put it here so that we have our origin in here. Here we have the x-axis, here we have the y-axis, and we want to find the equation of this line. We can use the slope-intercept form for this because every line can be written as y equals m times x plus b. M is the slope of my line, and B is the point where my line intersects the y-axis. Because my line goes through the origin, then my B is going to be 0. So I can insert the 0 for the B already. I don't have to write down plus 0 at all. So the only thing that I still need here for my equation is my slope m. And how can I find the slope of my line? I have to take a look at a triangle where my line is part of the triangle. So for example, if I take this big triangle here, I only have to know the length of this side and the length of this side to find the slope, because the slope is defined as rise over run. How long is this side? It is part of this square here, and we know the length of this side here is 16, so the length of this side is also 16. So my rise, when I go up, is going to be 16. And what is my run? That is what I go from the left to the right. So this part here, 6 plus 10 plus 16, is equal to 32. So my run is 32. 16 over 32, I can reduce this fraction because both numbers are divisible by 16. 16 over 16 equals 1. 32 over 16 equals 2. So I have 1 over 2 here as my slope. So instead of the m here, I can write down 1 over 2, and this is the equation of my green line. And the question is, why did we need that in the first place? Well, we were looking for B1 and B2, and the line helps us with that now, because I can find B1 here at this point of the line and B2 here at this point of the line. So this is the y value at this point, and this is the y value at this point. Let's start with B1. What is my x value at this point? It is from 0. We go these 6 centimeters here, so 6 is my x value. I just have to insert 6 into this x here, and then I find my y value, so my B1. So I can find B1 by inserting 6 into my equation, so that I have 1 over 2 times 6. If I calculate this, 1 times 6 equals 6, over 2 equals 3, so my B1 is equal to 3. Okay, we found it. Same thing with B2, which is my x value at B2 here. It is 6 plus 10, so 16. So I insert 16 this time into the x, so that I have 1 over 2 times 16, and 16 over 2 equals 8. So my B2 here is 8. I found my two lengths. We can go back to our beginning. We needed B1 and B2. We have them now. So B1 is equal to 3. B2 is equal to 8. So for the area of our trapezoid, we have 3 plus 8 equals 11 times 10, and all of this over 2. 10 over 2 is equal to 5, so the area is equal to 11 times 5, which is 55, and we solved this problem. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of our next videos. Take care!